Hello students, in this video I will be discussing about sign convention to be followed for mirrors. Now sign convention means numericals in mirrors are quite easy because the numbers are not so complex like gravitation chapter and all. But the problem is with the sign. You have to be very specific with the sign, and that is the more confusing part. So which sign to take for what kind of image or object, that is given by a convention. Convention means general rule which everyone follows. So what is the sign convention we follow? Suppose we take the two axes, the y-axis and the x-axis. Then we draw the mirror. It can be a concave mirror or a convex mirror, keeping the reflecting side on the left hand side. So this is the pole position. Now we know that when we have drawn the ray diagrams, we have seen that objects always we take on the left hand side, and therefore object distance, which is indicated by letter U, it always has a negative value, because on the x-axis if we come this side it will have a negative value. This is 0, so this side it will be negative. Similarly, for a concave mirror, focus lies on the left hand side, therefore focal length for a concave mirror is negative. It is same for your concave lens, you will be getting a negative value. Next is object height. Now you must have seen in the ray diagrams, whenever we have drawn any object, we always take the object in the upright position above the x-axis. So any value above the x-axis, if it goes like this, it will have what? A kind of positive value. Therefore object height, which is indicated by letter H, always has a positive value. Now coming to image. So we know that image is of two types. So it can be real or virtual image. Now if we talk about real image, in case of mirror, real images are always formed below the principal axis. They are always inverted. So image height h dash will always have a negative value, because down this axis on the y-axis it has got negative value. So h dash will be negative for real and inverted image. Now when we if you refer to the ray diagrams, you will find that real images are always formed on the left hand side. So the image distance, which is indicated by letter V, will be negative for real image, because real images are always formed on the left hand side of the mirror. Now coming to virtual images. Now virtual image, if you refer to the ray diagrams, you will see that virtual images are formed erect on the upper side of the x-axis. So image height h dash will have a positive value for virtual and erect image. Next is image distance. So virtual images are formed behind the mirror. So behind the mirror on the x-axis, this side it will have a positive value. So image distance V will be positive for virtual images. And regarding the convex mirror, so in the case of a convex mirror, the focal length will have a positive value because the F will lie on this side. So that is the standard sign convention we follow to indicate the different signs for object and for image. Is that clear? Now we have two formulas to be understood. One is mirror formula. Derivation is not required in your course, so I am not going for the derivation. So mirror formula is 1 by F, that means 1 by focal length, is equal to 1 by V plus 1 by U. Whereas magnification, the formula is M is equal to H dash by H, that means image height by object height is equal to minus V by U, minus image distance by object distance. Now this formula has three parts. Whenever you will do numerical, you have to take any of the link between the three parts. It can be a link between M is equal to H dash by H, or M is equal to minus V by U, or it can be relation between these two parts, H dash by H is equal to minus V by U. So these are the things that we need to understand. Now we need to understand what is the let's say the magnification value, what the magnification values stand for. So suppose magnification has a value of greater than 1. So greater than 1 magnification means the image is enlarged. Why? Because since M is equal to what? H dash by H. So H dash is image height, H is object height. So if the numerator is bigger, numerator is bigger than the numerator, that means image height is bigger than the object height, then M will have a value greater than 1. So enlarged image, bigger than the object. if m has a value lesser than 1 value means 0.5, 0.25 like that. It is not minus 3. Minus 3, if suppose the value is minus 3, value is actually 3. So that is greater than 1. This plus and minus, it will indicate something else that we'll see later. So m is equal to h dash by h. So if h dash is less than h, that means image size is smaller than object size, then we get a magnification value lesser than 1, diminished image. If m is equal to 1, that means h dash has to be equal to h. So under that condition, magnification value is 1 and it indicates that the image is of the same size as the object. So these are the three things regarding the value of magnification. Now we come to the sign of magnification. If magnification has a positive value, so what is the formula? M is equal to h dash by h. So we know that h is always positive object height. So in order to get the answer as positive, so this h dash has to be what? Positive. So h dash, when h dash is positive, when the image is a virtual erect image. So having a magnification value which is positive, which has a positive sign, you will know that we are talking about a virtual erect image. Now if m has a negative sign, so m negative value, so m is equal to h dash by h is always positive, we know that. So if the answer we need as minus, so the numerator has to be negative. So negative positive, it will give you a minus sign. So when h dash is negative, that means your image is reverse image, ulta. So that is it, we are talking about real and inverted image. Now if you observe, magnification has no unit. Why no unit? Because it is a ratio of image height by object height, or image distance by object distance. So these are the things we need to understand under sign convention. So I'll try to explain to you with the help of an example. So the question here stands like this. An object 5 cm in size is placed at a distance of 20 cm from a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed to get a sharp image? Also calculate size of the image and state its nature. So one good thing about numericals in optics related with mirror or lens is that you can guess the answer beforehand by reading the question. If you can guess the answer, and guessing the answer will come only if you can visualize the image. And for visualization of the image, your ray diagrams has to be very clear in your head. Now what I am trying to say, you see here. First we write given, object size h. So you have to write the word object size as well as h. So object size indicated by letter variable h, it is 5 cm, positive, because object size is always above the x-axis. Object distance, here it is given 20 cm. So it will be minus 20 because object distance is always negative on the other side of the y-axis, left hand side. Focal length f, it is 15 cm given, but I have written minus 15. Why? Because we are talking about concave mirror. In case of concave mirror, you know, the f value lies on this side, so it will have a negative value, so minus 15. What we are supposed to find out? Image distance v question mark, size of the image h dash question mark. Now leaving everything aside, let us guess what the answer will be. So you see, focal length of the mirror is 15. So if f value is 15, what will be the value of c, center of tilt, center of curvature? It will be double. That means 30. Where is the object placed? Object is placed at 20 cm. That means we can visualize that the object is placed between C and F. Now you recall the ray diagram. When the object is placed between C and F, suppose this is P, this is F, and this is C. Suppose the object is placed between C and F, where is the image formed? We have to recall, that is the importance of ray diagrams. The image is always formed behind C. So that means when we will calculate the image distance, the value has to be more than 30 cm, which is the value of C. So if you get an answer less than 30 cm, your answer is wrong. Second is size of image. Now size of image, we know that in this ray diagram, if you recall properly, the image size is always large. It is enlarged image. So obviously the image size that we'll get, it should be more than 5 centimeter. And what kind of image will be formed? You read the question carefully. Where should we place a screen? You know that real image can be focused on a screen. So obviously we are talking about real image. And by our visualization of ray diagram also, we come to know that it will be a real image. So all these things, so our visualization is clear. So this way you have to relate your question with the ray diagrams you have learned. You have to think what they are talking about, where the image is being formed, where the object is placed, and depending on that you can guess your answer beforehand. And after you solve, you can relate with your observation. If you don't do that, whatever answer you will get, you will be putting it in your copy. You are not cross-checking or verifying. So that is the interesting part of numericals in optics. You can actually verify the answer. So we begin. 1 by f is equal to 1 by u plus 1 by v. So what we need to find out? V. So my advice is that whenever you do numerical, first you frame the formula. After framing the formula, then you put the values. Otherwise, after putting the values, if you try to shift left and right, many students, you all tend to make mistake in the symbols. So first I'll make the formula. I need v, so I have left the v here all alone. And I have taken 1 by u this side. So it has become 1 by f is equal to, minus 1 by u is equal to 1 by v. Now I write this right hand side on left hand side and this entire left hand side on right hand side. So 1 by v is equal to 1 by f minus 1 by u. Now I put the values. So minus 1 by 15, because f's value was what? Minus 15. So this minus sign, you better don't put it below, because many students get confused when we put with denominator, how it will go to numerator, all those things. You don't have to worry. Simply put it in between. 1 by 15, besides the by sign, you put this minus sign. And the formula, this is the minus of the formula. Remember that. Many students make mistake here also. Since it is minus 20, so they will write minus 1 by 20. They will forget to write. So this is the minus sign of the formula, and within bracket 1 by u, so 1 by minus 20. So this minus is the minus sign of the value, and this minus is the minus sign of the formula. So these things you have to be very particular. So a single step can create mistake for your whole sum. Minus minus plus, this is simple mathematics. So minus 4 plus 3 minus 6 divided by 60. So ultimately upon solving I get 1 by v is equal to minus 1 by 60. Now this is 1 by v. You are asked to find out v. So what you will do? Therefore v is equal to minus 60. We will reverse it out. So minus 60. And remember, sums in physics, whenever you get any answer, you always have to give a statement. So after writing, don't leave your sum here. You have to give a statement. That's a good habit that you can develop. So what statement will write? Screen must be placed 60 centimeter. Here I am not mentioning the sign. It must be placed 60 centimeter in front of the mirror. So these words in front of the mirror will itself indicate that there is a minus sign. Okay. Next we have to find out the size of the image. For that we have the magnification formula. There are 3 parts. I told you, you can take any 2 parts. Now what we have here, we have the size of the object h. We have found out v, we have u. So we'll use this part. So h dash by h is equal to minus v by u. I need h dash. So what I will do, I will leave h dash all alone here and take the h this side. So it becomes h into minus v by u. So h value is 5 into minus, this is the minus of the formula. And what is v? V we have got minus 60, so we have put minus 60. What is u? Minus 20, we have put minus 20. So minus of the values and minus of the formula separately you have to write. Don't confuse between them. So we cancel, it is 3, minus minus cancels out. So we are left with minus 3. So 5 into minus 3, that's your minus 15. So what we observed in the beginning, that our image distance should be more than 30. That is what we got. It is minus 60. Okay. The image will be enlarged. So it is an enlarged image because object size is 5 centimeter, image size is 15 centimeter. Here the statement you see that I have written, the height of the image is 15 centimeter and negative sign indicates. So I have written this as 15 and I have also told that there is a negative sign which indicates that the image is a real and inverted image. So this is a proper way of solving numericals related with optics. You have to be very particular what is given. Write in words, write the proper variable. Be very careful about the signage. You have to take a proper sign, minus or plus, depending on whatever information is given. While solving, it is always advisable that you frame the formula, put the values, and after finding the answer, it is advisable that you end with a concluding statement. So try to solve the other sums taking in view the different points which I have mentioned. Thank you.